Welcome to the laboratory work demonstration of the continuous fluidized bed drying process. So first I just start with a short overview about the equipment. So this is our experimental hall, and here we have a really big fluidized bed equipment with a lot of periphery apparatus. So I just want to explain first minutes what kind of these apparatus are. So the process chamber itself is located here, and above this we have a expansion zone. This is this one, and then the process gases even going more upwards through a cyclone, where we are able to recycle the selected dust back to the process chamber, and then the process gas is going through a huge filter, and then the gas can leave the experimental hall, or we can even use the process gas in a cycle. So we are cooling down the exhaust gas to condensate water from it, and then we just heat it up and use it again for the process chamber. So just go a little bit closer. So what we can see here, this is the tank which we are using for our spray nozzle. So we have a two-component spray nozzle which we can place in top spray or bottom spray configuration, and we can also see some devices for measuring inlet and outlet moisture content. So we're using infrared spectrometer, which we calibrate with a dew point meter. Here on the right side you can see the programming system. We have 3 screens where we can just observe and control all the necessary process steps. Just stop once more. So here we can see the process chamber, and later during the process chamber is closed by just moving the glass part back to this position. And what we can see is here, this is a classifying tube, so we are able to take out continuously particles from the process, and we can see the temperature sensor which is recording the bed temperature. Then we also have a sample taker, so we can take samples over this tube. So what are the process variants that we can realize with our equipment? So we can use it in batch mode and in continuous mode, where we can use a non-classifying discharge, or as I already explained, we can also use a classifying discharge. What else do we have on our equipment? So we have a internal sieve milling cycle. We can heat up the process gas as well as the classifying and the nozzle gas. As I already explained, we can use the process gas in a recirculation step where we just dry the exhaust gas before we use it again. Then we can use top spray and bottom spray nozzles. We can send back the collected dust from the cyclone to the process, and everything is controlled and recorded, and yeah, more or less in automatic mode. So this is done by a programmable logic controller. And yeah, what kind of data we can get from this equipment is we measuring the gas moisture content with this infrared spectrometer that I already have shown, and all the gas flow rates were just controlled and measured by mass flow controllers. We have the possibility of inline particle measurement with a PASM probe, and all the temperature and pressure sensors were recorded and used for controlling the process. And last but not least, we just control the spraying rate by a gravimetric, by a balance, and even we also have an inductive mass flow, yeah, liquid flow measure sensor. Now we just experiment. So once more, we just show the process chamber, and yeah, maybe this is also yeah, some parts of the equipment. This is the dehumidifier for the exhaust gas. So the exhaust gas is coming with a high moisture content and still some temperature to this heat exchanger. It is cooled down, so the moisture is getting out, and after this the process gas is heated up in our electric gas heater, and then it is coming back to the process chamber. So in the next movie I would like to show the start of the fluidization process. So we have now some wetted material inside the process chamber, and you can still see the classifying tube. So let's have a look how it looks like when we just start the fluidization, when we just switch on the ventilators. There it is, a short blow up, and now it starts a little bit to fluidize, but as the particles are still really wet, some of them they start sticking on the window and on the walls of the apparatus, and the fluidization is really bad in the beginning, but yeah, the drying continues and the fluidization gets better and better. So in the next video we are just a few minutes further in the process. So let's have a look how it looks now. You can see the fluidization is really good, and some of our particles just fall into the classifying tube, and they will discharge from the process. So yeah, this is the typical particle movement in a fluidized bed process. Now we just show you how we feed continuous or semi-continuous wetted material into the already dried fluidized bread process. So we have a bath or a hopper where we have wetted material, and over a vibration feeder this material is just flowing into this valve. So it's collected for a few seconds, and after this is full, this discharged into the fluidized bed chamber. So you can see now particles has left. And now I would like to show how it looks like when this kind of wet material enters into the fluidized bed process. So please observe a little bit here. It will just come from here and then just get into the fluidized bed process. Yeah, here you have seen it just get into the fluidized bed, and then it's just mixed immediately with the rest of the material. And last but not least, I would like to show you how we discharge our particles from the process. So for this we just use the classifying tube. This is this one here. from the side the classifying gases coming, and here's just a simple valve, and after some seconds it will open and just discharge some of the collected material. And maybe we just have a short look to the temperature curves of the process. So we can see inlet conditions are continuous stable, and the temperature increases during the drying process, and then we just start after some minutes the charge of wetted material, and then the bed temperature and outlet temperature will decrease in the process. This can be observed quite easy from the temperatures. Thanks for your attention.